Hey everyone, this is Elaine, and in this video I'm going to talk about X-rays, definition and types generated. X-rays are photons that originate in the shell's region near the nucleus. Another example of photons is gamma rays. In the video Radioactivity Part 1, I talk more about it. If you have not watched it, the link is in this video description. So X-rays are photons. Let's remember some of the basic properties of photons. They have no mass, no charge. They carry energy and momentum, which are dependent on their frequency. They can have interactions with other particles. They attenuate exponentially with the thickness of the absorbing medium. There are two different processes by which X-rays are generated. One generates a characteristic X-rays and the other one Bremsstrahlung X-rays. Characteristic X-rays. We have ionizing radiation, which can be an electron, a photon, a proton, for example. So ionizing radiation interacts with an atom and ejects an orbital electron, creating a vacancy. This electron is from an inner shell. When a vacancy is created in an orbit, an outer orbital electron will fall out to fill that vacancy. In so doing, the energy is radiated in the form of electromagnetic radiation called characteristic radiation. So let's go step by step. Here we have an ionizing radiation interacting with an orbital electron, in this case from the K shell. The electron is ejected and we have a hole of vacancy at that shell. This situation is unstable for that atom and needs to be corrected. How that's done? Outer shell electron will fall out to fill that vacancy. In the process, we have an emission of a photon called characteristic radiation or characteristic X-ray. It is called characteristic because of the photon energy is characteristic of that atom and of the shells between which the transition took place. In this case here, the characteristic radiation is characteristic of those two shells here, which is from a shell is the K shell and the L shell, where the transition took place, and the characteristic of this atom. Because of that, a characteristic X-ray has a discrete value. Bremsstrahlung X-rays is the result of radiative collision, interaction between a high-speed electron and the nucleus. The electron, while passing near a nucleus, may be deflected from its path by the action of Coulomb forces of attraction and lose energy as Bremsstrahlung radiation. Bremsstrahlung can have any energy, ranging from 0 to the maximum kinetic energy of the bombarding electrons. Because of that, they form a continuous spectrum. So let's go step by step here. We have an electron being accelerated towards this atom here, interacting with the electric field of the nucleus. It's a high-speed electron. The electron is deflected from its original path and it is decelerated. It is slowed down. As it does so, it loses energy in the form of electromagnetic radiation called Bremsstrahlung radiation. The X-rays here, the Bremsstrahlung radiation can have any value. It will depend on the energy of this electron here and how it is deflected, how it is decelerated, and how much energy it loses. So Bremsstrahlung X-rays form a continuous spectrum because of that. And the direction of emission of Bremsstrahlung photons depends on the energy of the incident electrons. So we have let's take a look at this picture here. We have an electron beam, a target. The electrons are being accelerated towards the target and the X-rays are being produced here. For electrons energy below 100 keV, X-rays are emitted in all directions, as we can see by the blue curve here. So the emission is isotropically. As the kinetic energy of the electrons increase, the direction of X-rays emission becomes more forward oriented. So we can see that 400 keV here, 4 MeV, 20 MeV. When we get to 20 MeV, the emission of the X-rays is pretty much straightforward. Because of that, in megavoltage X-ray tubes, like the ones we use in Linux, we have transmission type targets in which the electrons hit the target from one side, like this one, from one side, electrons coming from one side, and the X-rays are generated on the other side. Here's a graphic representation of the two types of X-rays. Y-axis we have relative intensity of X-rays, how much photons are produced, and the x-axis we have photon energy in kiloelectronvolts. This curve here represents the Bremsstrahlung X-rays. We can see that the photons can take any energy value from 0 to the maximum energy here. In this case, 150 kiloelectronvolts. And here we have the characteristic radiation representation, which is a peak in the curve, because the characteristic radiation is a discrete value. Next, I will talk about diagnostic X-ray tube and linear accelerator. It is an overview about them. Links are in this video description here. And those are the sources I have used for this presentation. So this is it, guys. Thanks for watching.